This lesson is on geometric sequences. These are sequences that have a common ratio, so they're either multiplying or dividing by a number throughout the sequence. So let's take a look at an example of a geometric sequence. 8, 4, 2, 1, 1/2, and then it would go to 1/4 and so on. So what's happening? It's actually dividing by 2 each time. So this idea of multiplying or dividing will cause it to be a geometric sequence. The best way of writing it is in terms of multiplication. So if it's actually dividing, we can see it as multiplying by a half, multiplying by a half. That way you can use exponents to summarize how many halves you've multiplied by. So from 8 to get to a half, you've gone 8 times a half. How many times? 4 times. However, this is the 1, 2, 3, 4, 5th term. So A5 is 8 times 1/2 to the 4. So this leads us to the nth term being 8 times 1/2 to the power of n minus 1, one less than the number of the term. And in general, this leads us to the following formula for the nth term of a geometric sequence, being the first term times the common ratio, which in this case was 1/2, and to the power of 1 less than the number of the term. Now, how do we find the common ratio? Well, in general, we want to take any two terms and divide the second by the previous. So the n plus 1th term divided by the nth term. And so all of those ratios should be the same. So let's take a look at this example. We have a geometric sequence that starts with 3 and has a common ratio of -3. So what does that mean? Well, that means we're going to start with 3, and then we're going to multiply by -3, which is -9, to get the next term. And then we keep doing that. So -9 now is multiplied by -3, which gives us 27. And then that's multiplied by -3, which is -81. And then that's multiplied by -3, and that gives us 243. So what's the 15th term? How do we figure that out? Well, what's happening is we're starting with 3, so that's our first term, and multiplying by the ratio -3 to the power of n minus 1 for the nth term. So the 15th term is going to be taking 3 times -3 to the power of 14. And we can find that on our calculator. So 3 times -3 to the power of 14 gives us this nice big number. What about finding the general term? So here we have A1 is 10. That's our first term. Great. So AN, our general term, we'll start with the 10 and multiply by the rate of 1/2 to the n minus 1 times. Here, our A1 is -2. So we're going to start with -2 and multiply by the common ratio, which we don't know yet, to the power of n minus 1. So what is the common ratio? Well, you should be able to take any two and divide them by each other to find what it's being multiplied by. So the common ratio is actually -1/2. And now try that with any two numbers, and when you divide the latter divided by the first, you'll end up with the common ratio of -1/2, leaving you with the following general term. Now, what if we want to find the 25th term? Well, first we need to find the general term, and then we can plug in the 25 for n. So here, we have 2 as our first term, and our ratio will be 2√3 divided by 2, which is √3. Now you can check the ratio with the other, but it will still give you √3. So AN is then 2 times √3 to the power of n minus 1. Therefore, A25 will be 2 times root 3 to the power of 24. And you can use your calculator for that. 2 times the square root of 3 to the power of 24 is this nice big number. What if we have these numbers? Well, here, again, we're given no information about the first term or the ratio, so we need to use our formulas and see what we can do. Here, A3 is 0.006. So we can replace the A3 with 0.006 and say that we're taking our A1 times the ratio to the power of 3 minus 1, which is 2. So it's A1 times R squared, and this other one is 0.000006, and that's A1 times R to the power of 5. So we could solve this one for A1, for example. That'll be 0.006 over R squared, and plug it in by substitution to the A1 there. So you'll notice that this will give you 0.006 over R squared and then times R to the 5. So you actually are taking 5 minus 2 to simplify these, which will end up with R cubed. So now you'll be able to find R by first dividing both sides by 0.006, leaving you with 0.001 as R cubed, and then taking the cubed root of that to give you R to be 0.1. So the ratio is 0.1, and we can also find the first term by plugging that in here, 0.1 squared, so that's 0.006 divided by 0.1 squared, which gives you 0.6. So that tells us that A1 is 0.6 and the ratio is 0.1. Therefore, we can find the nth term as 0.6 times 0.1 to the power of n minus 1. And therefore, we can now find the 25th term of this second example here as 0.6 times 0.1 to the power of 24, which is 6 times 10 to the power of negative 25. So it's a very, very small number.